Hey, I'm Alan Furstenberg,
And I'm Mark Tucker. Welcome to Two Voice Devs.
Two Voice Devs. Hey, Mark, how's it going?
It is going pretty good.
Good
I've
to
got
hear.
I've got something that I've been looking at, just kind of one of those things that somebody passed off this a link to me, and I started looking at it and got a little bit excited about. So it's one of those. Here's something I learned. I'm just going to share it, and I may be just a step or two ahead of you as far as I've read the documentation and I kind of understand the context of where it fits in. Um, but it is along the lines of MLOps. Um, so,
Okay.
so in your mind, what is DevOps?
I was afraid you were going to ask something like that. Because I was going to try to get the answer out of you first. Um, I think of DevOps as this kind of crossover, as the name kind of implies, between the developer world and the operations world. And it's this space where you actually need somebody that's familiar with both worlds. So you've got people who are familiar with building tools, and what they end up doing are building tools to make your operations easier, faster, better, et cetera, et cetera, et
Mhm.
cetera. But also, these are tools that take your specific operations. So it's your code, the stuff that you're providing to the outside world, and making it run in an ops environment easier, better, faster, et cetera, et cetera, et cetera.
Right. So you have some developers that focus on the front end. They're front end developers. You got back end developers. You've got full stack developers, right? So there's different flavors of developers that do different things. And at some point in time, you need to build and deploy your service or your application into some environment. And especially if it's a bigger environment, like an enterprise wide environment, then you might have local data centers, you might have deployed cloud services, you might be using things like Docker or Kubernetes. You might use different build tools. Like, what are the build tools? You could use Jenkins, or you can do, there's lots of different things. Do you have integration with GitHub Actions? So this is kind of the world of where you need a developer that specializes in the how do we build and deploy and maintain this in this environment? How do we do it in a consistent way? So that's your DevOps. And not to say that you can't be a backend developer and also do DevOps stuff. It's, you can still wear multiple hats. But it is a specialty because you're learning different tools, you're learning different libraries and architectures and,
But
services that you wouldn't necessarily need to know if you were just focusing on a service or an application.
right, and I think what's important to realize is that not only is there crossover, but there has to be crossover.
Yes.
It's important to realize that you're getting somebody that has to be familiar with both system administration operations and the development. The how do this got built somehow. It got built to work on particular platforms. That's wonderful. How do you run those platforms? How do you make sure those platforms, can scale and can work? And it's not just it's a space in between, it's a space that overlaps and it has to overlap. Okay,
So
so that's
so
DevOps.
yeah, so
But
what would ML ops be? What are new artifacts, assets, things that happen in the ML world that's new and kind of different?
well, I mean, I guess I could say it can be a bunch of things. So it's on some level, it's how do you manage those prompt templates and how do you store them in a good way? And when we're talking vector databases, how do you make sure those vector databases scale and are responsive? Even to the point of, if you've got an AI scientist who is building new models for you,
Yep.
once they've built that model, well, what do you do with it? And this has actually been a complaint of mine for a long time, is that I talk to a lot of AI engineers and they're doing some amazing stuff, but then putting that, you then say, okay, what do I do with this? How do I test it? How do I put this into production? How do I make it so that I have, 1,000 web clients that can hit either this model or a scaled out version of this model? And they give me this response like, well, I have a Jupyter notebook.
Yeah.
And I'm like, well, that's wonderful, but I don't.
Yeah. So yeah, so that's exactly, that whole skill of ML ops is, could be quite broad. And some of the actors are data scientists. It could be, model engineers. It could be developers that are using a model. It could be, how do you deploy a model into your environment, into your enterprise? So there's just kind of new things, but they're kind of in some ways similar to things that we've done. It's just different files, but now we're dealing like with 450 megabytes or 2 GB for all the model data stuff, depending on the size of the language model that you're using. But how do you package up that, and maybe you're fine-tuning a model based on something from Hugging Face, and so what was the data that you used to train it? What was the data that you used to validate how it worked? What if there's some code that would be either like, here's the code that you use to train or fine-tune this model, or maybe there's some code that you have that would be, here's my inputs and how I start, and I need to generate other, kind of intermediate data files that in the end are going to be either used in the training of the model, or maybe you want to package up that model in such a way that you can deploy it to some registry out there.
And then, and then over time, you're going to need to train this model further. You're going to find problems with the existing model, and you're going to want to update it. And how do you make sure that the update behaves the same and can work the same? And how do you do A/B testing between the two? And how do you
version it?
How do you version it? How do you migrate over to it? Lots and lots of questions.
Yeah. So the thing that we're going to talk about, zoom in today, is something I learned about just this last week called KitOps. KitOps is an open source tool, and it's about packaging up a model and giving it a version number, any code, any data files, and any docs into a single file that can then be versioned and put someplace in a registry, a public or private registry, so that later you can pull that out and use it. So like, what would be, so imagine we have some sort of a directory structure that has code, and under the code there might be multiple directories that have different, let's say Python files that do different things, train the model or do other things. There might be another folder that's called data, and that's different, whether you're training data in JSON format or comma separated values or whatnot, and a validation file, and maybe there's some intermediate JSON files, maybe there's some configuration files, and then you have a models folder, and then you've got this fine-tuned model that you actually trained and fine-tuned for your specific purpose, and maybe that's stored as an H5 file, which is one of the different file formats you can save models in.
Okay.
So let's say that this is all in this GitHub repository, except for you may not actually want to package or keep the 2 GB.
I was going to say, do you want the trained model sitting in GitHub?
You probably don't, and so but you might want to have all the rest of the stuff, and at least locally or in some sort of kind of build infrastructure. Maybe you can build it on that kind of build agent that files there temporarily, just to the point where you can then package it up and deploy it to some registry. So I keep talking about a registry, and I'm like,
you're using that term specifically, I have a feeling.
Yeah, and we'll get to that. But like, if I were just to try to solve this problem and I didn't know about different things that existed out there, I'd be like, well, I want all this stuff in a single file. I guess I could zip them all together into a zip file and just name the zip file a certain thing, and then put it out on some S3 bucket and say, pull this zip file from this S3 bucket, and it includes all the stuff that you need.
Makes sense.
Yeah, so that's one approach. This is where I get to talk about Docker. So Docker is a container that includes code that you can execute, and where it usually starts off with is that you've got some sort of a code repo that includes all your source files, and you include a Docker file. And then you can execute Docker commands from the command line interface. You can do a Docker build, which goes through and reads the Docker file, and it maybe starts with a base image based off of Linux, and maybe it includes Node.js in it because maybe you're doing a Node project. And
right, so it includes the entire environment. So, and that environment may be your interpreter, it's the web server, it's all of the components that this image is going to need to run.
Right. And in the end, the thing that you end up with when you do a Docker build is an image. And the image is just everything it's a single file of everything you need to run this code someplace. You can start up Docker and just run it locally. You can use Docker as a container inside of a bigger environment like Kubernetes. So you've got this Docker image, but you need to put this Docker image someplace that you can get access to it. And that someplace is a registry. So Docker Hub is one of the public registries, but there are lots of different things that can host a Docker file, and you can push something to a Docker registry, a Docker compliant registry, and you can pull this image out by some sort of a tag, and usually a tag would be like a version number. So you can, say, give me this file, this app, the service, whatever, version 1.0, and then it would pull that over, and you can build a newer version and push a 1.1 version, and you can then pull that instead, and there's a problem with 1.1, so you want to revert back, so you'll push the 1.0 again. So you've got lots of different options, and you've got everything that you need to execute this code in this single file. Everything that goes together is there in that file, and it's versioned. All right.
Okay.
So that's kind of Docker.
So Docker basically, it gives us an easy way to to reproduce this precise environment.
Yes.
And it's everything that we need, and
it gets rid of it works on my machine type of issue, because if you build something up as a Docker image, then it's the same Docker image that I'm running, that somebody else is running, and that environment, that container that's running is based off a specific version of an image, and it has all the stuff. And so there isn't file incompatibilities or dependency incompatibilities, because
it's all the same.
You start off fresh inside of your Docker image, and you only put the things that you want in there. So, all right. So that's Docker. But what kind of happened is that people saw that there was a need to put other things in a registry, a single file, and then the way that the file format is, the image format for a Docker image is structured is kind of special, but it's also could be generic. It uses namespaces, and it uses hashes and blobs and things. And so you're like, well, how could we use this for something else? And so there started to emerge this standard. The acronym is OCI, so like this Open Container Initiative standard.
Because we already have, I've got to tell you, we've got a whole bunch of different OCIs out there, and I work for one of them. So this is
that's funny.
That's inconvenient, but okay.
So you could use Docker Hub could be a registry. Amazon has their Elastic Container Registry. Google has one. Microsoft has one. So there's lots of different registries that are available that are OCI compliant. And what OCI compliant registry means is that it's got the ability to push an image and pull an image, and that the format or kind of the file structure of the image follows certain standards of how it's structured, but it doesn't really care about what it is,
Okay.
right? It could be code, it could be a data file, it could be a README. It doesn't really matter. And you can have multiple of these artifacts inside this single image. All right.
Okay.
Okay, so I'm going to go ahead and share my screen and we'll walk through this KitOps website here and just
Okay.
talk a little bit more about kind of how this all fits together. All right, so we're looking at the KitOps website, and the URL is KitOps.ml. And KitOps is an open source project, and it's talking about how do you share these machine learning specific artifacts, whether you're a data scientist, an application developer, or others that are working on managing and hosting your own, AI models. And so a data scientist could, work and fine tune and figure out a model and package it up in such a way and deploy it someplace that then later I can just grab version X of that from this registry, and then I can start using it. So it starts giving us a workflow where we can have somebody focus on something that a task in the realm of machine learning that they're good at, and pass the data on through this concept of a registry and versioning. So that's kind of the main thing. So we talked a little bit earlier about having a repo that was used for our model, and there were different folders, one for code, for docs, for data, for models, etc. So inside of that same directory structure, there would be a Kit file. And the idea of a Kit file is that it's a single file, YAML-based, that's going to talk about the different things that are important for kind of our package, the single file that we're putting together. So there's some required sections or some main sections. So here's a package section, which you can name like what this thing is. It's a model for a fine-tuned BERT model, or it's whatever it is. If there's any licensing, I think there's even a versioning that you can do at the package level. At the code level, you're saying inside of this package, this image that's going to get created and deployed to a registry, I want to include everything that's in the notebooks folder in my current project, and that's going to be assigned. It's everything in there is code. For model here, it's going to be everything that's in this folder here. It can be a folder, and it would get all the files in a folder, or it can be a specific file if you had a specific file. Here's the version of the model. So you're keeping track of it individually of the version of the model. And you can say like what framework it was, any licensing that goes along with it. So you've got, once this image is built, it's going to pull everything from notebooks, give it kind of a designation of code, and put that in the image. It's going to put everything that's in this folder here under model. Here's some data sets, like here in this case, you've got a training CSV file and a validation CSV file. So that's going to be assigned to the data sets section. And there's also a doc section that's not shown. So what happens is that there's a command line tool called Kit File.A. And when you do Kit pack, it's going to find this Kit file. It's going to read through it and start putting things in and building this image. And then you can push that image and give it a tag to some registry, and later somebody else can pull that image based off of that same tag and then access it. At which point, when you unpack it, you can either unpack the whole thing and you'll give it a directory of where it's going to unpack. It would copy the contents out of this image and put it back on your file system. Or you can say, the only thing that I care about right now, I know that the model's in here and the data sets and stuff, but the only thing I care about, like maybe I have a service that's running and I want to load up this model, then I can have my service pull a specific image by version, by some version tag, and just only pull out the model. I don't need the data. In that case, I don't need anything with data or code, but you get to decide how much or how little you package up in here. You might release a kit that just includes the model. You might include lots of stuff.
So hang on a second. So you said you'll be able to take it and unpack it and put it into your file system. I guess that kind of started messing with my head, because I thought part of the point was that it would not be putting it in your file system. It's putting it in this virtual file system to make sure that you always have a, that it's accessed in a consistent way between developers.
Yeah, so that's where the kind of the analogy between Docker falls down, because Docker is like, I'm running code. And so I do want that environment to be the same across developers or deployments or whatnot. This is just all about the files. So like a data scientist could do stuff with the model and package it up into this and push it to a registry. Me as a developer, I want to do some testing locally. So I'm going to pull that image, and now I'm running locally on my computer, and it's copying those files out for a specific version. Now I have it locally on my box, and I could run it locally and run queries or inferences against that model. But then I can also create a build tool that says, when I build this, then I'm going to pull this from the pulled information, because I can have, like, the data scientist could run this pack, but a build tool could also run pack. So you could have a build tool that uses your code repo, and it pulls down the base model from Hugging Face. Inside that repo is the data file, which is going to help you train or fine tune that model. And part of that build process could then call kit pack and kit push to deploy that image to the registry. Now there's a build tool and an automated pipeline for, how do I build this model based on a specific set of training data? And it gives me some place to put that, those files that are important, but all packaged together. Now I could have a service that's running in my environment. And when I start up, maybe there's a environment variable that says, I want to use this specific version of this model. So when I start up, I can run kit pull as part of the startup process. I could download those files, so now they're in my Docker image, because my service, let's say my service is running in Docker. I could pull that model down, and then my service finishes starting up, and it's using that specific model. So now when I hit my REST API endpoint to query the model, it's using a specific version of the model that's then like running locally in memory, or inside of some sort of cluster.
Okay, so as part of this, you said you can build a build tool, or you can build one of these other things. Is any of that already built?
So what you would do is that inside your build pipeline, let's say you're using Jenkins for your build, there's already the capability of running command line tools or executing code as various steps inside of a pipeline. So you could configure your Jenkins build to have a step. It would have a Python script, for example, that would pull down the model from Hugging Face and take in your training data and start to build it. And then you could have another step that after that build was successful, then you could push that, create, kind of package up and push that image, that file, to some registry. So that would be another step in your custom crafted Jenkins pipeline, or your build process. So it allows you to fit in the model training and the more specifically the packaging up of the artifacts that are important to keep and to version together into one file and put it into a registry.
Okay, I think. Okay.
So the last part that I just wanted to bring out on this website was the thing that gets built. So it's the Kit CLI that uses this Kit file that we've got shown on the screen that creates an image, and that image is called a model kit, or just a kit for short. So here's the if you think of this kind of this box representing a single file, the thing that's in this file is the Kit file. It's got your model that's, and some of these things are optional, but you've got a serialized model. There's something called a manifest. And this is actually something that happens with Docker images. You can look at a Docker image and you can see the manifest for a specific, for the contents of what's inside of that Docker image. So they followed that same pattern and that same standard. And so there's a manifest of what's inside of this image or this kit. This would be any code files that were that you decided to include in it, any data sets. So then this whole thing gets packaged as one unit, and that thing could be labeled, a tag, usually a version number put on it, and then stored in a registry, and then pulled out later when you need it for something else.
Okay.
So it's very special purpose, but it's an interesting blend of solving the problem of how do you pass around this information or these models and any of the important files, whether it be code or data or docs that go along with it. And this solves that specific problem.
Okay. I mean,
Right.
I'll be honest. I've sort of got it. I'm sort of trying to wrap my head around why, not so much why this is important, but why this, I don't know, maybe it's, what is the advantage of this over just duplicating something from GitHub or, putting it all into a zip file?
Yeah, so that's a good question. One, if it's a zip file, you still have the problem of where you're going to store this zip file. Are you going to email this zip file around to everybody? Or are you going to put it on an S3 bucket?
Okay, that's a fair
And
point.
and then
Okay.
have to give somebody access to that S3 bucket. It gives you an easy place to be able to log into a registry and pull something down by name and tag. And so then that just facilitates I can put something in a registry and I can pull it out. And that can be whether it's like me manually wanting to do something with it on a local machine, whether one data scientist is wanting to pass something off to another data scientist to do some additional work on something. It just gives it a standard way of packaging all the things that you need up into a single file, put it in it someplace that's easier to pull out later on.
Okay, fair.
Yeah. Plus you don't have, like the concerns if you were to just include the 2 GB model file inside of the GitHub repo, then you have to use large file system and all the different things that go along with how do you, and you still have the issue of like how are you going to version these things, and the fact that you've got this image file that you can version and store and pull out by version is something that would be really helpful in a pipeline or kind of in what would be standard DevOps, but because it's specifically models and data that goes along with models, then that's why it's called MLOps.
I'll be honest, I'm having a little bit of a hard time wrapping my head around this completely, but I kind of get it. I guess I guess I can certainly see how this is useful for data scientists as they're working on building and refining a model. Still trying to wrap my head a little bit around exactly how does this help us deploy that model in a production environment. I mean, I can see the versioning aspects. I can certainly see elements of it, but I'm still having trouble wrapping my head around it. But that's something I'm still having trouble wrapping my head around in general. So
yeah, so for example, you could have, and this is one workflow that you could see. You might have a data scientist that's working in their Jupyter notebook, and that's kind of like where they're comfortable, and they're working on different things and trying to figure out how to fine tune this model and what data and all the kind of prepping of the data for that. And they finally come up with something like this is good. Well, a lot of the code from the Jupyter notebook you could take off into its own script file or Python file that's then included as part of a repo. So now let's say you've got, here's the data to fine tune this model. My script file, my train.python file is going to pull the base model from Hugging Face, use the data, and then build a model And so you could create a, the data scientist can work with the developer to create that script file that's going to be in their GitHub repository. But right now there's nothing big in there. It's just some data files. Comparatively, you could have large data files, but compared to like the model that's going to be built from, the result from that is probably not super big. So now your GitHub repo includes everything that you need to train the model, but it doesn't include the base model or the fine-tuned model inside your GitHub repository. So then that same developer or some DevOps developer is going to say, now here is our enterprise build process. That, one of the steps is going to be to pull down this code from this repo. Then I'm going to need to provision a GPU someplace. That's going to be part of the step of the pipeline. And then another step is going to be, let's go ahead and train the model. And in the end, in that folder is going to be this, like one of the options, and what we're using is an H5 file. So that H5 file includes all the stuff from the fine-tuned model, and it's 500, 600, 700 megabytes, whatever. And so now you're like, well, this build environment, this kind of agent that got spun up to do this build, is this a transitory thing? It can't live there, that file. So what are you going to do with that large model file now? So the best thing to do is put it someplace where you can get access to it later. So that's where, at this point, KitOps would fit in, and you would run the Kit CLI tool to go ahead and push, pack the image, and then push that to a registry. And then the build's done. It's got something there. And so now you can decide later, as a developer, I want to pull that image down locally and do some additional things. Some other data scientists could pull it and do some additional things. Or you can say, I want to use this as part of my production. I'm going to write a service that's going to have a REST endpoint that's going to pull this model. So now all you have to do is figure out how to get the model from the registry to the Docker image that is the service. And so now you've kind of solved that glue of how you connect things together by pushing something into a registry that you can pull out later.
Okay. I guess I'm still wrestling with this, but it makes sense, and I can see why it's useful.
Yeah, it's not for every situation, and if it depends on what type of machine learning that you're doing, and it also depends kind of like how big of an environment you're having to do this in.
Okay, very interesting. Certainly, it's one of those. We talk a lot about the tools that developers need to use, and it does sound like this is a useful tool in our toolbox again. It's more of the it's the ops side tool, as it kind of suggests. So I'm interested in what other folks think about this. How will you use this as part of your setup? What other tools are you using to do this sort of thing? Have you found a better solution? Is this replacing a worse solution? We'd love to hear it. Feel free to leave comments below or reach out to us on social media. And we will discuss these sorts of things another time on Two Voice Devs.
Two Voice Devs. Thanks, Ellen.
Thanks, Mark. Have a great week.
You too.